there, welcome back to your algebra class. We are still in Unit 4. We are on, technically, it's kind of tricky. This is lesson 8, but it's actually day 2 of parallel and perpendicular lines. So we're in the same concept as the previous video, which was lesson 7, and I called it day 1. We're on to lesson 8, but it's really day 2. So don't be too confused by that. Basically, you can just pick up wherever you left off in your notebook, and let's keep going with parallel and perpendicular lines. So this is going to get a little bit more involved, and you're going to need your thinking cap on. Might need a calculator, wouldn't surprise me. And 100%, I just can't emphasize this enough. You absolutely should be writing these examples in your notes. Okay, these are going to come in handy as you're doing your assignment and any future quiz or test. So let's do a quick little review about parallel and perpendicular lines. Let's remember that parallel lines, or the equations for parallel lines, have the same slope. So parallel lines have the same slopes. Remember that. On the other hand, perpendicular lines, or the equations for perpendicular lines, have slopes that are negative or opposite, reciprocal. So one will be positive, one will be negative, and then whatever the slope fraction is for one, it will be inverted or flipped over for the other. So that's super duper 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 important for today. Also important for today is that you understand how to use point slope form. Remember, y minus y1 equals m parenthesis x minus x1. We're going to be using that. And you have to understand that your equation should be written in slope intercept form, y equals mx plus b. So stick with me on this. I'm going to try to not make this like a 45-minute video. I'm going to try to get through it as fast as I can, but it's a lot, okay? So bear with me. First example, it says, write the equation of the line if it passes through the point negative 2, 7, and it's parallel to this line represented by this equation. So what are we trying to do? We're trying to write an equation for a line that is parallel to this line, but our second line, the one we're writing the equation for, passes through this point of negative 2, 7. Now, step 1, I'm going to tell you, is always to pull the slope out of the equation that you have. Remember, we're looking at equations for 2 lines. They'll give you the equation for one line. You need to pull the slope out of that equation and use it along with the ordered pair that they're giving you to write the equation for the other line. Okay? So, step 1, pull the slope out of the equation they give you. The slope here is negative 4. Now, we're looking for parallel. That means same slope. That means for the equation I'm about to write, I can keep the slope negative 4. And the line that I'm writing the equation for passes through this ordered pair, or this point of negative 2, 7. So we need to use the point slope form. Remember, that's this guy. So we're going to start, now that we have our slope, that goes there, and we have our ordered pair, that goes there. Let's do that first. Y minus 7 equals the slope, which is negative 4, because it's parallel, parenthesis, x minus negative 2, which is really x plus 2. So we're getting there, right? We've got our slope, we've got our ordered pair, we've got our point slope form. All we have to do now is manipulate this equation into slope intercept form, which we did. We did that in a previous lesson. So we're going to distribute the negative 4. And then the last thing is to solve for y. So instead of subtract 7, let's add 7 to both sides. There you go. Y equals negative 4x minus 1. This line, represented by this equation, is parallel to this line represented by this equation. So this is our final answer. We wrote an equation of the line that passes through this point and is parallel to the line represented by this equation. These two lines are parallel. They have the same slope and different y-intercepts. I told you this was a lot. This is algebra class. Let's do it again. Notice it's parallel. We like parallel. Parallel is good because it uses the same slope. Step 1, get the slope out of this equation that they give you, except, don't you know, we can't see the slope because it's not in slope intercept form. So now we have to rearrange this hot mess so that we can find the slope. So I can't even do step 1. I have to back up and solve this equation for y. So I need to subtract x. From both sides, which I just did. Now I need to divide everything by negative 3. Everything gets divided by negative 3, which makes it positive, like so. Okay, so now this equation for this line has been rewritten into slope intercept form so that now I can see the slope, and the slope is 1/3. And since it's parallel lines, we know we can keep our slope 1/3. Now, I've got my m. Here's my ordered pair. I'm going to use point slope form. Y minus negative 1 would be plus 1 equals slope of 1/3, parenthesis, x minus 3. Right? Distributive property. We've done this before. Right? Distributed. And now solve for y by subtracting 1. There we go. This line with a slope of 1/3 is parallel to this line with a slope of 1/3, but notice they have different y-intercepts. This y-intercept is negative 2. This y-intercept was negative 3. These are parallel lines. Same slope, different intercepts. Okay? You're like, no, not really. Well, now we're going to make it even a little bit more tricky because now we're going to do perpendicular. First things first. It says perpendicular. Let's pull the slope out. And good thing, this one is already written in slope intercept form. The slope is 2. So this slope is 2. But for perpendicular, I need negative or opposite reciprocal. So instead of 2, which is really 2/1, I'm going to flip that fraction over and I'm going to take it from positive to negative. So the slope I'm going to use is negative 1/2. Right? Opposite reciprocals. So this is the slope I'm going to work with now. Here's my ordered pair. And I'm going to do point slope form. Y minus 3 equals negative 1/2 x minus 4. I'm going to distribute that negative 1/2. Negative times negative makes positive. Half of 4 is 2. And solve for y by adding 3 to both sides. There you go. You just wrote the equation for the line that's perpendicular to this line and passes through the point 4,3. Again, notice the slope. Negative 1/2, positive 2/1. Those are definitely perpendicular. Another example over here. Of course, they aren't nice. What's my first step? Pull that slope out. But you can't see that slope because it's currently in standard form. Yuck. We have to rearrange. We have to solve for y. So let's subtract 5x. And then everybody gets divided by 3. Oops, that should say minus 7. Okay, so the slope of this line is negative 5/3. That's this line. I want perpendicular, so I need to take their slope for this line and flip it over and convert it from negative to positive. So my slope is going to be positive 3/5. This is the slope I'll be working with. It is negative or opposite reciprocal. Now that I've got the slope I need, here's the ordered pair. I use point slope form. Y minus 1 equals the slope I need. X minus negative 5 is x plus 5. Distribute the 3/5. 3/5 of 5, or 3/5 times 5, is 3. And instead of subtracting 1, we need to add 1 to both sides to solve for y. Here we go. That is the equation of the line that is perpendicular to this equation for this line. Notice the slopes. These would be perpendicular lines if you were to plot them. Okay? Let's do some more. Let's do one more. Let's do one of each, and then we'll wrap this up. Okay, let's start with, I don't know, let's do number 2. No, let's do number 1. I like that it has 2 negatives. We're going to do number 1. And it's parallel. Notice it says parallel, so same slope. Passes through this point, parallel to this line. What's the slope? Slope is 2. So we get to use the same slope. Remember, that's the slope right there attached to the x. Okay, cool. So I use this ordered pair and that slope. Y minus negative 1 is really plus 1 is your slope. X minus negative 4 is really plus 4. Distribute the 2. Isolate the y by subtracting 1. There you go. Y equals mx plus b. Notice slope of 2, intercept of 7, intercept of 4. Same slope, different intercepts, parallel lines. Okay? Let's do a yucky one. I'm going to pick a really yucky one. I'm going to choose number 7. We are perpendicular. This one says perpendicular. So remember, the slopes are opposite reciprocal or negative reciprocal. So that means I need to pull the slope out of this equation, and don't you know, it's not in good form. It's a standard form, and we need slope intercept form. We have to rearrange. So we need to subtract this 2x, and then everything's going to get divided by 10. So subtract the 2x first. Here it is. Subtract the 2x on that side. And then everything's going to get divided by that 10. And you know what? You really should fix that slope, because the slope is negative 2 over 10. That's really negative 1/5. Let's keep it clean, right? Let's keep it in smallest terms. So this slope is negative 1/5, but I want perpendicular. So I need to flip this over, and instead of negative, I'll make it positive. So the slope I'm going to use is positive 5, which is 5 over 1. So I'm kind of done with all this. Now I'm going to focus on this ordered pair and the slope of 5. And I'm going to use point slope form. Y minus 3 equals my slope, x minus 2. I'm going to distribute the 5. And then solve for y by adding 3. There we go. Slope of 5, slope of negative 1/5, that means they're perpendicular. This line would be perpendicular to this line, or this line or this line, whichever equation you choose to look at. Those are perpendicular lines. So they are taking so many of your skills from Unit 4 and rolling them all together here. I mean, look at everything you have to do. You have to be able to rearrange from standard form to slope intercept form, pull out the slope, put it into lowest terms. Then you have to understand that perpendicular means the slope is the negative reciprocal. So we did that. Then you have to use point slope form. You have to distribute and solve for y to get another slope intercept form. I mean, it's incredible. That's how algebra works, right? I've described this before as like a big giant snowball, right? Think about making a snowman. Don't you first start with a little scoop of snow and you roll it into a ball in your hands, and you drop it down and you start rolling it around your yard. And the whole time you're rolling it, it's getting bigger, and you're forming it and you're rounding it out and you're rolling it more and it's getting even bigger, and you're forming it with your hands and you're rounding it out and you're rolling and rolling and rolling and rolling all around your yard until you have a really big snowball that becomes the first circle or base of your snowman, right? And that's how algebra is. We started way back in Unit 4 with the easiest concept of what is slope and what is y-intercept. And now we're taking all of that and we built onto it, talking about the 3 different forms for linear equations. We talked about how to manipulate those equations. We're also bringing in like distributive property. That's from Unit 2. Like, algebra is like building a snowman and starting with one single snowflake, truly. Okay? Just a little snowy, I don't know, example for you, or representation. Okay? Well, anyway, that's that. This is almost now a 17-minute video, so let's wrap it up. I hope this makes sense. I know it's a lot, but I'm only going to give you, I think it's like 6 problems on your homework today. So you don't have to do too many of these, but it is good practice. Ties a lot of your skills together. So thanks for watching. I hope you have some good notes. Be in touch as needed. Take care, and I'll talk to you soon. Bye-bye now.